Microsoft, based out of Australia. And with me is Alistair Spears here.
Hi, I'm Alistair Spears. I'm a Senior Operations PM for the Office 365 team. Grew up in Queensland, but I'm actually based in Seattle at the moment. So let's get started. We're looking for a theme for this presentation. We thought 8:15 in the morning, we're going to have to do cartoons. It's Saturday morning cartoons, so the only thing we're missing now is like a box of cornflakes or Fruit Loops or something like that to get started, and just kind of ease you in to TechEd. So what we wanted to cover this morning was really the IT perspective of Office 365. Talk to you about what Office 365 means from an IT perspective. We've been at Office 365 for quite a while now, BPOS before it. It's about 5 years of learnings we have now of operating these massive cloud services. So we really wanted to share those learnings with you this morning. Also, we wanted to talk about some of the cloud approaches that we've taken at Microsoft to solve some of those traditional IT problems around deployment, management, and operations, areas that are near and dear to my heart. And then we'll talk about what we've seen for the new role of IT. What we've seen for customers that have been on Office 365, that have gone through many of the upgrade cycles now and seen that for real, and how that's actually changed their IT operations and the new roles that they're doing instead of perhaps the old roles that they used to have as well. So before we really get started, let's talk about Office 365 from an IT perspective. Who in the room is using Office 365 today? Show of hands quickly. Great, about half of them. Anyone on Live at EDU, the education offering? No? Okay. Anyone considering Office 365? Great. Who's on Exchange 2003? Anyone? Group-wise, Lotus Notes, distant memory for, a couple, yep. All right. So in Office 365, what we like to think of Office 365 as really a federated set of productivity services and applications. When we think about Office 365, it's not a product per se. It's not one thing. It's not one super architecture that does all these different things. Most of us kind of understand it's a cloud-hosted version of SharePoint, Exchange, Lync, now Yammer. But also, above that, it's also our productivity application suite as well. These are the kind of traditional apps that you install on PCs and devices. This is known as Office 365 Pro Plus for the core Office. We have Project Online. Visio for Office 365. We have mobile access apps, web apps, and those sorts of things as well, to really bring not only the collaboration side, I'm going to put this down.
That's a good idea.
Yeah. Not only the collaboration side of the Office platform, but also those productivity apps, those core things that get work done. So those are things that we're all pretty familiar with IT. We've been using those sorts of applications for many years now. And where Office 365 starts to get a little bit different is some of the things that we build on top of that core platform as well. Consolidated user experiences. When we take a look at what we can do now with having SharePoint and Exchange and Office and Lync all running at the same time, we can start to do some interesting work on combining a lot of those products together to make very different user experiences and interesting scenarios that cover the entire suite of whether you're sending an email in Exchange or you're sending a Word document through SharePoint. We can have a consolidated set of e-discovery resources across that single platform, a consolidated search index across that, even a consolidated search layer. But this also extends to things like the sign-up experience. When you're signing up to Office 365, provisioning a new tenant, when you're administering a tenant, it used to be the case that you could know everything it was to about the Exchange Management Console. You took one look at the SharePoint Admin Center and you'd have no idea. And so what we're trying to do now with Office 365 is really blur and simplify that approach so that if you're an IT person, you know how to use Exchange Online, you can still manage SharePoint Online because more and more we're being challenged to manage more of the workloads at the same time to get that total result together as well. And this is not too dissimilar to what we did in Office back in the day as well. If you remember back, Office used to be a discrete set of applications. It was Word, it was PowerPoint, it was Excel. And it took us 11 releases of Excel before it was the most popular spreadsheeting engine. It took us 9 releases of Word. Back then, there was WordPerfect, Lotus 123, and those sorts of things. But why Office won out in the end was that we were able to have a consolidated user experience across all those applications. We were able to say that just because you know how to copy and paste in Word, you can copy and paste in Excel in the same way. And in many ways, we think of Office 365 as that same productivity enhancement for IT pros. So now you can manage all of these different workloads at the same time at this consolidated platform. So under that, there's a lot of things that you may or may not see as well. There's kind of a consistent commerce and billing engine. There's an identity platform based on Azure AD. There's a service management layer, and there's a network infrastructure. It's all running Office 365. And these are the things that you don't necessarily see, but we're going to drill in a lot more of today as well. So before we get into more of Office 365, let's kind of position how we think of the cloud in general at Microsoft.
Thanks, Al. So, as Al said, we've all heard about the cloud, and it was about 2-3 years ago now, our illustrious CEO turned around and said we're all in with the cloud. And the interesting thing around that was that the claims that came out around cloud after that announcement were claims of this wonderful fairyland of lollipops and rainbows, where ITs would just skip through fields of daisies, not having to worry about whether the servers were up, whether people could access their information, and it was all this big fluffy happy place that you're going to get to in the cloud. And the interesting thing is that when that those kind of claims came out, I was still I was working in this space, and a lot of the people would turn around and go, this is what cloud is, right? Is cloud this kind of, this place where I can look off to and just have everything work for me perfectly? And the truth is that, it's never been that. The truth is the cloud is not, and I've actually had to say this to some of my AMs, the cloud is not an actual place in the sky where things run. We don't have Zeppelin data centers floating around the world that actually have all this stuff running in them. It's physical data centers. It's just a new way of doing the computing. And so when you start to think about what the cloud actually is, there's actually a lot of hardware behind that, right? It's a big-ass set of data centers that we run to be able to do the cloud. And so when you start to think about what the move to the cloud is, there's been a lot of fear, there's been a lot of crazy claims around what the cloud's going to give you. And the truth is, not all of that's always been true. The other big one we've seen as well is hosting providers today who have gone, we're not going to give you cloud, because it's the buzzword that sells our hosting service. But the truth is, it's just a hosting service with a new name. But the cloud has given us some good things. How many people here have a Hotmail account? Welcome to the cloud. So the truth is that the cloud today has been around for a long time. It just hasn't been buzzworded yet, right? So you think about Hotmail. It's one of the biggest public email services in the world. It continues to grow and continues to serve everyone. It's a consumer-based service. It's free. It's easy to use. Online gaming has benefited from cloud services in a huge way. Xbox Live is still one of the biggest paid online subscription services around, all running in the cloud, allowing people to be able to game and play with each other easily as part of that. Social and storage, so SkyDrive and Twitter and Facebook and those kind of places are all cloud-based services. They're all running, they're all consumer, they're easy, and they've given us a great amount of growth, and they've also helped build a lot of trust with cloud-based services once people actually make the connection. But when you start to think about cloud, we really put cloud into one or two buckets. And the first is the consumer cloud. Consumer cloud is free, consumer cloud is easy. It's usually funded by advertising, so you think about YouTube and you start to see all the other videos that come up on the side. You're either a person who has a lot of lolcat videos or a lot of movie trailer videos that comes up depending on what you look at. You as a person are the commodity in these consumer services. It's your search results, it's your information that now becomes valuable. And the interesting thing around that is that while you're using a product, the truth is what you're getting there pales in comparison to the information about you that's actually used to run those consumer-based cloud services. And that's really where we start to look at, it's great because it helps us scale and it really helps us innovate in that space. But an enterprise-grade cloud is very different. An enterprise cloud is really around actual paid service, an SLA that ensures that service is up 99.9% of the time. You have full 24/7 support. And this is one of the things I have conversations with customers a lot of times about, where they turn around and will say to me, we're just going to continue to use Skype instead of Link. What's the difference of that? What's the impact? It's free for us to use Skype. The truth is it is. You can use Skype, you can call anyone you want. But from an enterprise perspective, if Skype goes down, who do you have to call? Who do you pick up the phone to? Whose throat do you choke to say, why is the service not running?
Yours, Ben.
But the truth is, you don't have that support for a consumer-grade service. For an enterprise service, you do, and that's where Office 365 comes in. You're the customer in 365, which means, in the old adage, the customer is always right. You get the support and you get everything you need as part of that.
So when we think about Office 365, in the Office team, we really look at these design goals. And just to be kind of completely transparent with our business model, if you like, for Office 365 is you pay us money, we make you work better. That's kind of the Office business model. So it's not about advertising, it's not about market research or anything like that. It's a very simple services transaction when we're looking at that sort of thing as well. But when we design Office 365, when we look at building new capabilities, there's really two sort of big trends that we like to focus on when we're doing this. First is kind of that traditional Office work of the tools you need to do your best work. We've been doing that, the Office team, for about 30 years now, and we continue to do that. What's different today is that as we're expanding beyond kind of the PC monoculture into PCs, devices, tablets, smartphones, web apps, and who knows what the next big tablet or device will be. But all these new devices that are coming out, we want to make sure that Office is a tool that you can do your best work on all of those platforms and do the stuff that you need to do your work. At the same time, there's so many benefits from Office 365 of not having to worry about patching your server, not having to worry when hard drives fill up and those sorts of things. But we still want to make sure that there's that enterprise-grade control in the Office 365 services as well, so that you have that same control and even deeper control than you have perhaps on premises as in Office 365 as well. And this by no means we'll discontinue offering on-premises software. We'll still have Exchange, we'll still have SharePoint, we'll still have Lync, we'll still have the traditional Office clients as well. But we do expect over time, over the long term, the economics of Office 365 will win out for most customers. We'll keep selling it while you keep buying it, but we think over time it will probably change to be a much more cloud-centric model, just as the economics of that stack up. And if you think of some of our early customers that moved to BPOS and then Office 365, one of them Starbucks, for instance, or Coca-Cola Amatil here in Australia, they've had 3 free upgrades in that time. They haven't had to do that big, complex project to move from 2007 to 2010, 2010 to 2013. Now it's just expected. Now all of that big, chunky capital expenditure is just done for them. So on top of that, there's 5 big trends that we're also working on as well. We kind of have these quests that we're going on and looking at in the engineering teams and how we can improve these particular aspects of productivity for people as well. A really dynamic workplace is something that we've been focusing on a lot as well. We see the organizations have changed quite dramatically now from a place where you had a lot of employees inside the building and then you had everyone else outside the building, and it was kind of IT's role to be gatekeeper of that organization. Now when you have contractors, vendors, joint ventures, external people, partners you're collaborating with, customers you're collaborating with, you have a much more dynamic and porous workplace. And so we've been focused really hard on how we evolve a lot of those capabilities so that you can collaborate across organizational boundaries easier and easier. When we're thinking about making sense of it all, we're really talking about the amount of data we have now in our business intelligence systems, in databases, even just in email. The amount of email we can do now. Last week we upped the Exchange storage rate to 50 gigabytes for every mailbox. And so with that amount of information, it's really important that we have new business intelligence tools and new systems to be able to make sense of all that data in a much faster way as well. We see the world of home and work starting to merge more and more as we focus on these trends. People will be working from home, people will be doing home stuff from work and all those sorts of things. You see the rise of bring your own device, the rise of using smartphones, and those sorts of things as well. So we want to make sure that's an easy experience for either IT to manage and enable, or still be able to lock down the things that you need to lock down in certain environments. Natural expression. This is the ability to not just use a tablet, not just use a keyboard and mouse, but start to use things like touch, voice, and gesture recognition, and those sorts of things as well. And a lot of people ask us, when will we have like a tablet version of Excel? And I couldn't think of anything worse than a bunch of rows and columns trying to use a finger to enter in that sort of thing. So it's not just about taking the apps, combining them, and making a tablet version or anything like that. It's about rethinking what makes sense on those particular scenarios. What are the scenarios you want to do on that device? What makes the most sense on a 10-inch screen versus a 27-inch screen versus a 50-inch screen, and those sorts of things as well. And finally, information responsibility and the responsibility of IT to manage the organization's core assets, the intellectual property, the confidential information is becoming more and more important. And we're seeing that as governments, as industry bodies get more and more sophisticated with how they approach IT, the regulatory or compliance burden is increasing as well. So we want to make sure that that doesn't overburden you as IT professionals as well. So let's talk next about some of the kind of enterprise challenges that we have in IT and the sort of things that we see. And to be honest, I like to dumb it down into the kind of these two areas of IT challenges. It's building the stuff and it's managing the stuff as well. When you're building stuff, it's really hard to get that scalability model right. Oftentimes you might start with a pilot, put in one server, you need to grow to 10 servers or 50 servers as you go down as well. Reliability, efficiency. And then on the management side, once the systems are in place, once you're running them, how do you keep them controlled, keep them secure, and keep them compliant? So in this next section, we want to take you through how we approach this in Office 365 to meet some of the challenges that you guys see every day and how we can start to meet that in Office 365 at a much bigger scale as well. So Ben, let's talk about scalability first.
Thanks, Al. So when we start to think about scalability in the service, I get asked a lot of how many users do we have on Office 365? And the truth is, by the time I'd finished telling someone what the number was, that number would have changed. We have at any given time hundreds of millions of users running on Office 365 worldwide. Now, if you think about that and just kind of let that compute and sink in for a little bit, what does that mean from a hardware perspective? What do we need to be able to service those users? And what does that mean we need to be able to do to ensure that every user, when they go to hit their mailbox in the morning, gets their mail come through in a timely fashion? And so from a Microsoft perspective, we approach this on a global scale. We have a number of data centers worldwide that run the Microsoft, the 365 service. And a data center for us is basically anywhere from 60,000 to 100,000 servers. Anything less than that for us is not a data center, it's just a server farm sitting somewhere and it's probably under a really big desk somewhere, right? The truth is, for us, data centers are huge. Data centers are not something that, it's just rack space in a data center somewhere, or it's not just this nice little colo rack shelf. It's actually a pretty big undertaking for us to push a data center out. And what we do is we have data centers that sit all around the world. So for 365, we break the world up into 3 simple regions: APAC, Europe, and the US. And then what we do is have geo-redundant data centers that sit in each of those areas to ensure redundancy and high availability of those services. What we then do is we bring in our content delivery nodes. And our content delivery nodes, or these CDNs, are where we then start to have faster egress points back onto our service. So rather than needing to trawl the internet or traverse the internet connection all the way back to our data centers to get your mail, we have these little egress points that act as mini data centers where we'll actually start to pull people back in. And then when we start to think about that, we also then have links around the world, which will then go and keep those data centers connected as well. And those links will then are managed by Microsoft and maintained by Microsoft over dark fiber to ensure that we're getting the connectivity we need to be able to manage these services. When you start to think about 365 and you think about what we're doing overall in the Microsoft space, all of these services are managed and maintained out of Redmond. We have guys that sit there, logging into servers when they need to be able to go and maintain those servers, fulfill service requests, etc. So we need all that connectivity in there from our own perspective to ensure that we can do that and keep those servers up the 99.9% of the time that we say we do.
And it's a very highly automated system as well, but we do have kind of people all around the world. In fact, in Melbourne, we have our security research center that plugs into this environment as well to make sure that everything is safe and secure. We look at a follow the sun model around the support, so at any time we always have people on duty managing the service. So even though it's highly automated, there's still a human in the loop at all times with this thing, looking at proactive as well as reactive analysis of the system.
Now, one of the things I'm going to call out here as well is that, we've got a nice content delivery node showing up there in Australia. We also have new data centers that we announced coming up in Australia as well. Now, these will be Azure-based data centers that we'll be using to host more cloud services around our infrastructure space and our platform space locally in the country. But just to call out that as we continue on down the track, this is stuff that grows. This isn't nothing we do in this space is static, okay? You look at how 365 runs, we're always about how do we make this service better, how do we make this service grow and improve as we move forward. So as we tend to come into a deeper amount, and we'll jump from the US back to this region, what we then do is there's only so much you can do with putting a content delivery node in a data center on the internet somewhere, right? So what we have is we have our content delivery, our data centers and our edge nodes that are set up and ready to go, or our content delivery nodes. But then we need to start and think about, well, that content delivery node still sits on the internet. How do we get then from that node out to you as the customer? And we do this by engaging with our ISPs and internet providers. Providers like Telstra have peering with Microsoft to ensure that they have faster routes back from their point of presence back to our edge nodes to ensure that as you're hitting the internet and you're saying, I want my mail, I want my SkyDrive Pro, I want to get on a link call, you're actually getting the best possible latency as part of that, and to ensure that you're not stuck for ages just downloading that new lolcat in the morning. But of course, we also take advantage of other technologies that are out there. HTML5 has been a great advent of being able to do asynchronous processing and have a lot more processing happening on the client side than we've ever had before. So we take advantage of these technologies within the Office platform to ensure that we're able to do things locally and ensure that people are connecting over the most optimized route as possible. Link is also a great example of this. If you're doing a peer-to-peer call with someone on Link, you're not going back up to a server in Singapore to be able to get some sort of traffic route back and forth. Link will actually find the optimized path over your network locally from one peer to the other to be able to have that call. The moment you bring in a third person, we'll then start to route a little bit further out. But when you start to do those peer-to-peer calls, we'll take advantage of that local network traffic to ensure that latency is as low as possible.
So when we look at that environment and kind of look at it at just Exchange, what does it really look like to manage kind of the Exchange grid of servers in this particular environment? So Exchange, for those that understand Exchange, it's a fairly straightforward environment in Exchange 2013. You have CAS servers, mailbox servers, arrays into CAS arrays, database access group arrays, or as the Americans say, DAG arrays, which I always find kind of funny. But really to manage that entire environment, that entire fabric of Exchange Online, we look at a lot of data center automation. So much so to the point that we don't actually patch these servers. We just rebuild them. We scrap them, start again, rebuild them. So at any given time, we probably have about 5 or 6 different operating environments of Exchange out there in the fabric. We just kind of quiesce them, bring them off rotation, move mailboxes off them, and put mailboxes onto the good ones, take them offline, format reinstall, start again with a new one, rejoin the appropriate array, and so on and so on. So all of this is managed essentially with PowerShell, with a lot of scripting, a lot of telemetry to run this sort of system. And this is how we can roll out new patches and manage this very big environment across the world as well. We do, as Ben alluded to before, we do divide our organizations up into regions. And so we don't actually share mailboxes outside of those regions, for instance. And then we do that for a number of reasons. Firstly, there's some technical implications of knowing which data centers we're using, keeping the traffic as local as possible in that environment. But the bigger one is legal and compliance related. We're absolutely of the opinion that we need to keep our data in the same legal framework as our customers are operating in. So if you're operating in Australia, your data is still subject to the laws of Australia. If you're operating in the US, it's subject to the laws of the US as well. So it's important for a data sovereignty point of view that we keep the data in that same area with that local regulations, local government standards as well as we go through that as well. And that's not just a physical thing, that's also an operational environment, that's a legal and kind of a functional level view of compliance as well, rather than just a physical location issue as well. If we look at SharePoint, for instance, and again, SharePoint and Exchange look kind of totally different from a data center point of view. A SharePoint infrastructure, if you just want to advance a few, you kind of start with AD, some SQL, you build on top of that with all the web front ends and different application pool roles on top of SharePoint. And essentially we take all of that environment, that SharePoint environment that you probably build on-prem, and wrap it up into something we call a stamp. And so when we want to scale out SharePoint, we essentially just copy and paste that entire environment and roll out a stamp at a time. About 150,000 user capacity at a time is kind of our scalable unit there as well. And so we deploy a particular tenant or a particular SharePoint site across multiple of these stamps. And so to upgrade, it's a matter of shutting down that stamp, moving it over to a new stamp, and so on as well. So we don't even look at kind of what's happening with our web front end, what's happening with our SQL database or something like that. We look at the health of the stamp the whole time. And then of course we have that stamp replicated not only inside one data center, but load balanced and across a separate data center as well. So that if anything goes wrong with a particular stamp, you can keep up and running on a totally separate data center as well. And then on top of that, there's a lot of infrastructure that we do that is very much specific to SharePoint Online. These are things that we've built around essentially to manage this big grid, manage the, you can imagine the queuing users and queuing different customers to come onto different environments, making sure there's space, making sure a stamp doesn't fill up, load balancing all of our users across all those stamps. It's kind of a big deal. So there's a lot of other things that we've built, operational processes around this approach as well. The nice thing here is that the entire SharePoint environment is actually run on Hyper-V. So every single one of these servers is actually a virtual machine. So if you're worried about SharePoint scalability even on premises in a virtual environment, very scalable, and we notice almost no difference when running SharePoint online in a Hyper-V fashion. So kind of to think about the scale that we get out of Office 365, it really allows us to do some big things. 25 terabytes per tenant, 25 gigabytes SharePoint storage per user. Exchange Online is now 50 gigabytes per mailbox, and then unlimited archiving if that's what you desire as well. We run hundreds of millions of mailboxes through that. We have a cloud app model to allow a hosting of other apps to run inside this environment as well. And it's all this infrastructure, this global network of data centers, these logical architectures that we deploy to really allow us to deliver this at a really cost-effective price of $10 a month, $15 a month, $20 a month, whichever plan you're particularly on as well. So let's talk about reliability now. And Ben, perhaps you can take us through some of the reliability things we do to run this service. It's great to have scalability, but without that reliability, you're really missing something.
And you're right, having all that scale and having the service down means you have this really big data center shaped paperweight and hopefully a big pile of paper to put it on at some point. And the truth is, when we start to think about, reliability in the service, it all comes down to the nines. How many nines do I have? Do I have 5 nines or do I have 9 fives? What's the uptime and how do we look at that? And from a Microsoft perspective, we look at this on a number of different levels. And the first is really around redundancy. Making sure that the service can fail over as quickly as possible is key to us, and that redundancy sits in a number of different spaces. Physical redundancy around hardware for the network, for the servers, for those Hyper-V environments, so that when something goes wrong, we can very easily and quickly fail over to another set of hardware. All data redundancy, ensuring that we have backups in case of catastrophic failure of a data center, something going down. But more than likely, failing over to another data center data set so that we can pull data back or move people over as required. We actually had an instance a number of years ago now, and it was back in the BPOS days, where one of our data centers, actually the power grid was struck by lightning. It was a really interesting story because it really kind of pushed some of this redundancy piece and what do we do. And back in the BPOS days, we ran in an active passive scenario, one data center up, one data center ready to go on warm standby. Power grid was hit by lightning, which kind of screwed up our UPSs, so we couldn't fail over power quickly, and basically all of Dublin went down. It wasn't just us, it was every other data center around there as well. We had this point where we had to make a choice of, are we going to fail over to another data center, which I think was going to take us about 4.5 hours to do, or were we going to wait and see if the power company's promise of getting power back up in 4 hours was going to come through? In this instance, they decided to wait. It came through and we were all back up. But we were there ready to go. We would have been able to switch that over had that taken any longer and actually start to get that data center back up and running and ensuring we were at. And as we move forward into today's scenario, if that was to happen today, people would have been switched directly over. Because we run in an active scenario, the ability to fail over 50% of the workload into the secondary data center is much quicker and much easier. And in fact, when you look at what the RPOs and the RTOs are on something like Exchange today, I think the recovery point objective on Exchange Online, and if you read the service description, clearly states it is a near instantaneous recovery point objective for Exchange Online. We are constantly replicating that data between both to ensure that redundancy. So resiliency, this really kind of follows on from what I was saying here. Active load balancing, ensuring that both data centers are going to be sharing that load. If you run on a 365 service today, you'll probably realize that some of your users connect to Singapore to get their information, and some users will connect to Hong Kong. And that's how we then go and split that load between both data centers and ensure that when we're looking at having a service that's up and responsive all the time, is that we're making the most of our hardware that's there. We don't have this big investment in another data center that sits there doing nothing. It's active, it's running, it's keeping your data going, and it's ready to take the other 50% of the load at any given time.
Okay. In the case of Exchange, we'll spread out that one user mailbox at least across 4 different servers between 2 and 4 different data centers, depending on the region. So that's really ensures that if something goes wrong, you've still got an active mailbox copy on a complete separate set of hardware, whether it's a rack failure, or a room failure of the data center, or an entire data center out, there's still a backup, and there's still multiple backups around that as well.
Now, the interesting thing here is that all of this, resiliency and redundancy is great. It's useless if you don't test it. I remember I worked once with a gentleman who was, that was his job, was to test DR, and he took great pleasure in walking into banks and ripping hard drives out of servers in the middle of production environments to see if their DR was actually working. And that was his job. He would go in and test that stuff to see if they could recover from those kind of failures. Well, I don't think we have guys going in absolutely ripping out hard drives at random. We do failovers on a regular basis. Everyone's heard of Contoso and Litware and those kind of places, yeah? Our faux companies that we keep for all our demo environments. So they all exist in Office 365, and we fail these companies over regularly to ensure that when push comes to shove and the chips are down, we actually have the ability to do this and know exactly what to expect and how that failover is actually going to work. As Al said, we distribute our workloads throughout the environment as well. This is for everything that sits within 365, Exchange, SharePoint, Link, our commerce platform, the admin portal that you log into are all distributed across both environments. This is to ensure that everyone can get access as they need to. As we said, 100 million users, or hundreds of millions of users hitting this service all at once means that we need to be able to distribute that load to different servers so that no one's going to get that kind of timeout message or a little, we're working on it dial while they're logging in. So this is something that we want to make sure that we can do to ensure that all the components are up and running, and that everything sits where it should. We also ensure that everything's isolated. So if you look at the health dashboard within Office 365 today, we don't just have his SharePoint up, his Office up, SharePoint up, his Exchange up, his Link up, but you'll actually be able to go down and see, is the SharePoint service up? Is the logon service working? Is SharePoint team site creation working? You'll be able to see different components of that service and if they're up and running. And what this means is that if we have an issue in one component within SharePoint or within Exchange, it's not going to pull down the entire environment as a result, which ensures that you're getting the best experience as you make your way through. Of course, none of these data centers work unless we've got some level of human interaction sitting in here as well. We have automated systems that will go and make nasty phone calls to people, and these people are the people on engineering teams who need to fix stuff. When things go wrong, there are guys in Redmond getting dragged out of bed to ensure that this stuff's getting fixed. And the beauty of this is that these people are part of the product team. These are the guys writing the code. These are the guys who are actually building the software that runs on the servers who need to fix this. And the benefit here is that now, rather than having a bunch of propeller heads sitting in a closet somewhere coding away for us and throwing stuff over the fence, and then every time they get feedback from someone around how it doesn't work, rather than them going, well, it's not my problem, I'm working on the next feature, this becomes their problem. When things break, these guys are actually getting dragged away from their families, away from their holidays, away from all of those things that they're coding away furiously to achieve, to ensure that this service is working. There is a new level of responsibility within the product group, so much more than just, am I putting a new release out there for people to use?
It's actually a big change over the last 5 years for our teams as well. And my team's regularly on call for these sorts of things as well. And the experience is kind of scary when your phone rings in the middle of the night and you get an automated message from the Vice President of Engineering saying, this is Rajesh Jha, Vice President of Engineering. We have a SEV1 issue, please wake up. If you don't answer the call, if you don't get on the call, then your manager gets called, then his manager gets called, or her manager gets called. And so the escalation escalates all the way up to the top of the company and this sort of thing. And 5 years ago when we started this, there was uproar. The engineers hated being woken up. They hated being taken off working on the new cool stuff to work on the other stuff. 2 a.m. in the morning, didn't get sleep, and then having to go into work and do their day job as well was a huge issue. But funny thing happened after about 6 months. The code started to get a lot better. We started not having these things. I mean, it's great for us, that we've had a long history of building Exchange products and SharePoint products and Office products, and then giving them to you. And then 3 years later, we'll come back and we'll fix those problems. You could call up for a hot fix, but the time to get a hot fix is like 4 weeks as we do all the testing and those sorts of things as well. But feeling the pain has been a very important learning point for the last 5 years as we've gone along this journey with Office 365. Feeling that pain actually goes directly into the product and actually improves a lot of these things that I'll touch on in a sec.
So next is around inspecting what's happening in the service and ensuring that what we're doing here, we can see what's going on, we can predict what's going to happen with the service. So if you recall, I sat down, I was talking about our issue we had in Dublin. we have tracking and monitoring tools that run across this service that log what's going on, that see what's happening in the service, and help us to kind of predict when things are going to fail, when things are going to go wrong, when things are going to be fine and dandy, and we can let the engineers sleep. In the Dublin scenario, this is one of the things that started to work into our protocols and procedures. Like I said, power grid got struck by lightning, and one of the first things we noticed was that our UPS and our power was out of phase, and literally the order of events was, wow, that looks funny, and then everything went down, right? But now we have processes in place to identify that kind of anomaly and know what the cause of that could be and how we can combat that, how we can then go about getting power back to the service to do that. And that exists throughout the entire 365 service. We have log tracking that will go through and see what's going on in the service, when servers are getting in capacity, when servers are starting to get to a point that we need to shut those down, move the mailboxes off, bring in a new stamp, whatever it happens to be able to bring those servers back up and ensure that you've got all the data you need moving forward as part of that. And then the last one is that when things go wrong, we want this to go down in a nice way. We don't want you getting to a point where if a server does fail, because servers fail, things go wrong, servers go down, It's why we have all of this redundancy and resiliency sitting behind it, is so when things do go wrong, they can go wrong, right? That we're not going to end up, you be sitting there all of a sudden halfway through a Word document in a web app and the IE window just crashes and disappears because the service died. You want to ensure that things go down gracefully, that another server comes in, picks up the load, and keeps that connection alive, that things will actually continue to work as we make our way forward. And so we have standardized hardware that we're running all of this service on. We have fully automated deployment scenarios for rolling out new servers. When you go and provision a new tenant, all of that stuff's automated. There's not a guy in the back sitting there tapping away going provision server with a PowerShell script. It actually goes off and provisions it for you. And then we have built-in workload management machines that are actually going to then monitor those workloads, monitor SharePoint, monitor Exchange, monitor Link Online, and ensure that things are up and running. And if it needs to provision new Hyper-V environments, can go off and do that as well.
Yeah. So let's think about how we do this on an engineering point of view as well. And if we look at all these services, very loosely coupled services, we're empowering our engineering team to run that service and to keep it operating at its best. There are some specialized roles that we have around data center design, physical data center design, and those sorts of things. But those roles generally look a little bit different to our Exchange engineers or our SharePoint engineers. And on the software side, the point of view is to just assume the software will fail, assume the hardware will fail, assume the network will fail, but make sure the experience doesn't. All of this stuff will fail. You can run on 2 nines if your service is that bad, or 2 8s even if it's that bad. But if you can deliver a 5 9 service on top of 2 8 architecture, that's the best thing that you can do. So essentially the way that we accomplish that is we divide these things up, and it's essentially a set of contracts or loosely coupled agreements between all these services of how the different experience will work. Windows Azure Active Directory. That's something not run by the Office 365 team, but it's used innately in Office 365. The reality is, the Exchange people aren't the best people to run Active Directory. The Active Directory team are. So let's let the Active Directory team run Windows Azure Active Directory and have a loose contract with that, how that works. And just like you may take your on-premises Active Directory, federate or synchronize it with Windows Azure Active Directory, likewise, the Exchange team then federates or synchronizes their directory, their user objects, with that Azure Active Directory. So even if something does happen with Azure AD, it goes down for whatever reason, Exchange will still kick along. There's no single point of failure in that environment as well. Then, of course, we want to make sure that even within the workload, that there's isolation between that as well, so that if you have a CAS array, there's multiple CAS servers at any given time serving your particular user base. There's multiple mailboxes always in action as well as we go through that. To kind of give you an idea of how we manage some of this stuff, we start to look at really deeply in system monitoring. And this is another big learning that you see in Exchange 2013 if you deploy it on-prem from what you may have seen with 2010 and 2007. There's a lot of these cloud learnings now built into the product. One of the kind of interesting factoids, if you like, the old Exchange management pack for SCOM had 1,700 different alerts that would fire at any given time. That was great for engineering and for support, because what we could do is go, that event's firing, this is the line in the code where that thing is going, we'll just throw an event It helps management, right? The more alerts you have, the better it is, the easier it is to kind of diagnose an issue and repair an issue as well. However, with 1,700 different alerts that could be firing, you don't necessarily know, is a customer impacted? And when you're running a service, as opposed to building software, the high order bit is to make sure that the customer is not impacted, rather than, can I fix the problem faster? So we look through that, and it turns out there's only 200 of those alerts that actually indicate customer being affected by something going on in Exchange. So with that sort of knowledge, then we can start to monitor those 200 alerts, have quick alerting on those sorts of things, and see when those events are flagged, we know that customers are down. If it's something, one of the other 1,500 events that's being fired, it can wait till morning. The Exchange guy can come in and look at it in the morning. It's not indicative of a failure in the system. But one of those 200 events fires, automatically starts waking people up or goes into recovery actions as well. Things like managed availability you see in 2013 are another way to try and have the software do it itself. Have the software fail over. It's smart enough to try and shut itself down, essentially blue screen the server and take it out of rotation and just let the other servers around it pick up the load and have no interruption to that service capability as you go forward as well. So that's kind of the inside monitoring. But then there's the outside-in monitoring as well. And if you're familiar with the context of witness servers and those sorts of things, we kind of take that to a next level as well. And from multiple points around, too far, waving my hand around, there. From multiple points around the world, not just our data centers, but also out in sort of customer-specific environments, we have a lot of these polling stations constantly pinging the Office 365 service, checking that not only is the web app available, is ActiveSync running, is the Outlook APIs running, is SharePoint running, and all those things around the world so that we know, and not just that something in the server is wrong, but sometimes there might be an issue outside of that we see from the outside in first, that we're aware of with synthetic transactions before we actually see it in the servers itself. So that combination is quite an interesting view here, and I'll show some of the tools we use that in a sec. On the SharePoint side, if we think about SharePoint, the SharePoint architecture from building a really reliable service looks a little bit different to Exchange for sure. But to kind of give you the context, let's talk through what happens when you save a document into SharePoint Online. Firstly, when you click Save, it's writing to a disk. Right? It's writing to that one disk. And so there's one copy of that document. The failure scope is essentially none. If something goes wrong in the service at that point of view, you've lost your document. So instead, we put that disk on RAID 10, make sure there's 2 copies of that particular document every time you hit save. But of course, that's not enough as well, so we'll synchronously mirror that to a separate rack inside of the same data center, and then use log shipping across to a separate data center altogether, so we have 6 copies of that document now. Then run scheduled backups, asynchronously replicate those scheduled backups across to essentially give you 10 copies of any particular document in the service. Now this prevents hardware failure, this prevents issues in the data center, corrupted disks, corrupted databases or anything like that to enter in. But there's another form of corruption in kind of your data, and that is your users themselves. And so to kind of counter that, we have our recycle bin built into SharePoint as well. We have a caching system built into Office as well, so there's a client-side cache for those documents just in case something gets interrupted as they save that document into the service as well. And then we have an admin recycle bin as well to help move the admin, help the admin control restoring those documents that the user may have deleted as well. So really there's a lot of these copies of that one document spread out throughout the environment. And when we give away 25 gigabytes of storage per user, you can essentially think that there's 250 gigabytes in the background of information stored there to make sure that you have a highly reliable service when it comes to SharePoint.
So with that, let's move on to some of the efficiency pieces we get from our data centers. And the truth is, when we start to look at the data centers we're creating on scale from a Microsoft perspective, there are certain efficiencies you can get with that as well. And now this comes in a number of different forms. It could either be from environmental efficiencies or power efficiencies. And the truth is, when we look at a data center today, this is what a lot of people will see from a data center side of things. Initially, it's just, cool, I've got a bunch of servers and I've got some power that needs to come in, maybe some water supply as well to try and keep that stuff cooled. But we all know that there's a whole bunch of other things that go in between that, right? We've got UPSs, we've got generators, transformers. We've got transformers that are running from the power supply. We've got computer room air conditioning. We have coolings and a whole bunch of other things in there, condensers, cooling towers, a whole bunch of stuff that goes into running that environment. Now, all of this results in power consumption. And that power is either being used for running your service, your environment, compute power, or it's being run to run all this other stuff, being used to run all this other stuff. And so with that, we look at how we actually take the energy usage within the 365 service. And initially, when you look at a standard data center, we're running it at what we call a power usage effectiveness, I think it's what, or power usage equivalency of 2.0. That means that 50% of the power going into the data center is actually being used to run the servers. It's not the most efficient thing, and there's a whole bunch of loss you make on cooling and lighting and all those kind of things. Those nice little hand scanners we have in there for security that actually do little access granted take up a lot of power. They need to be run, right? So when we look at a cloud data centers, we look at how we can then do things like widen the temperature range for servers, remove the need to have water-based cooling at all. And that gives us the ability to cut out a huge chunk of power and move us to a PUE of around 1.2, roughly. Standard cloud data center is running it around that space. As we continue to make our way forward, we've got a whole bunch of other things we can do with our data centers in the way we actually build them, the way we actually break ground on a data center to ensure that that efficiency can continue to be maximized as we make our way throughout. Like I said, the 365 service is not static. We don't look at going, cool, we've got a data center, we're happy. We're constantly looking at how we can make that data center more efficient. What new technologies can we use to be able to have a data center built up more quickly, scale faster, be more resilient, and be more power efficient than it ever has been before? So with that, maybe what I'll do is hand over to Al so he can take you through what some of these efficiency gains look like and how we've actually built those.
Sure. I'd love to bring a full data center here with you to show you, but instead I just have a couple of pictures. And it's really interesting when we speak to our data center team. They're a different type of engineer from a software engineer, right? They're usually an electrical engineering background or a thermodynamic engineering and those sorts of things. Really, they look at IT as kind of the customer. And their real concerns are about electricity and heat. So much so that when we're talking about building new data centers or those sorts of things, we don't say, how many servers do you need? It's a question of, how many megawatts do you need? And then we set megawatts, and then, well, it's whatever storage at the day, whatever servers at the day will use that amount of megawatts to work out as well. So this is an example of one of our newer data centers. This is a kind of a typical looking data center that you may look at, say, enclosed space and those sorts of things. But there's a couple of things that I'll draw your attention to, as we look through this sort of co-located data center as well. The first thing that you may notice is the door at the back. All of these units are sealed off and sealed and separate access control to every room inside of the data center that's running a specific workload. We absolutely do not want the Bing guys getting into the Exchange data center or anything like that. Hey, we don't even want the SharePoint guys to get into the Exchange data center. So all of these things are very separate, separate access control throughout the environment as well. It's also not set up to the Microsoft network. I can't just use my Microsoft building badge and get in. It's a totally different authentication protocol. It's a totally different multi-factor authentication that we go through as well. You also see those little red tags on the racks, each locked rack here. That's representing that this particular room is full of highly confidential information. It's full of PII information as well. And so it's just another visual warning to show anyone that may be working in that data center that this is very important data as well. You can see the cabling at the top as well. And from that cabling, if you're a cabling guy, you may see that that's actually optical network. So each of those racks is connected to optical fiber directly. That gives you kind of a view of how much information is actually going through that particular rack. And so the density of these racks is pretty high as well. You can see here a lot of the cabling. Believe it or not, we have pages and pages of documentation on cabling standards. It's very important to us that we're running 60 to 100,000 servers, that the cabling is identical and exactly the same. It's done so that we can be as efficient as possible to pull out particular servers, to route around particular issues or anything like that as well. Everything is color-coded, set up in different ways. And the hardware, when we buy the amount of hardware that we do, we actually build it custom. So we have our key hardware providers, and we buy enough servers now that we can actually specify the exact size of those devices. Do we need blinking lights in them? Probably not. Do we need VGA out? Probably not. So we can really specify that hardware down to a very fine-grained approach as well. Because in these sorts of rooms, we still need to move the air around. You can see here how we've compartmentalized some of our air handling units as well. So inside the system here, you can see those areas and pumping it through. And what we've found is that running this many servers doesn't necessarily mean you have to run it cool. Our traditional approach is to run very cold data centers because, hey, servers get hot, server heats up, stuff breaks. What we actually found was it wasn't really about the heat at all, it's about the airflow. So we can run a much hotter data center as long as we're moving the air through that data center as fast as possible as well through the servers. And the kind of thermodynamic properties of a server is such that it can pull the air from a cold zone or from a room temperature air, heat it up, and then as hot air rises, we can have, you just use the pressure differential of that to pull out the air out of the top and rehandle it as well. So that's kind of a traditional data center approach, traditional electronic systems to make sure we have high availability as we do those sorts of things as well. And this sort of data center is very suited to specific places. It's great when you're looking in close-off areas, when you need to build inside a building and those sorts of things. But as we expand faster and faster, it takes a long time to build these sorts of data centers. So we're looking at how we can expand data centers much faster. This is what we call our IT pack, or our IT pre-assembled component. This is essentially building a data center like you're building a Triton shed. Everything arrives in components, easily to assemble and up and running in a much quicker fashion as well. So what you can see here is you can see the IT load component down the bottom. Looks kind of like a shipping crate. Once upon a time, we actually used ISO shipping crates to do this. We had kind of a standalone ISO standard shipping crate that would be loaded full of servers and it would run. We'd just park it in the data center, plug in the cables, and away we went. Problem with that is, again, the thermodynamic properties of an ISO shipping container aren't necessarily conducive for running a lot of servers. So we've moved to this model now of building each of these pre-assembled components directly and essentially using our hardware providers to build to this specification so we can just plug and play just like Lego as well. On the top, what you can see going on just there is the air handling unit. So if you can imagine there, the room temperature air or the outside air comes out from the side.
We just lost.
There we go. It comes out from the side. The servers pull that air through, and as the air heats up, you see those air handlers and those louvers at the top are essentially controlling releasing that air as well. And part of that air is then piped back in to keep a consistent temperature through that server, even when there's temperature fluctuations outside of the building itself. On top of that, once that's all assembled, the next slide, you can see kind of what it looks like. You can see those air handling units setting on top. You can see those louvers on the outside that are essentially controlling that airflow in. And it really just looks like a shed. This thing is just built in the middle of nowhere and set up like that. And that is your server now. It's running outside, has a security perimeter around it. It doesn't need a roof over the top. It doesn't need, all those things that make buildings nice for humans to habitate in. Instead, this is a data center built for people, for servers first, not for people as well. It's kind of a horrible place to live in. The data center engineers here look more and more like truck drivers, and they plug and play those pieces and plug them onto each other, and away we go. So essentially then, let's look at some of the things that we do to manage that service as well. That's the hardware, that's how we build it, all the way from the kind of logical architecture, the network architecture we use, and the building itself. So Ben, perhaps let's talk about control next and what we can do to control the service itself.
Sure. So when you think about a service the size of Office 365, we have a lot in place to ensure that everything that's happening with that service is tracked and logged and monitored. We have a lot of control that sits over in there, and that's usually driven by standards. But when we look at how we actually control the service, we're looking at, and this is a little bit of telling you how to suck eggs with access control, right? But we look at really taking a fine-grained approach at role-based access control for the people who have access to the service. As I fondly call them, the grease monkeys in the data center, the guys who are actually in there pulling drives out and putting servers back in when we're in that rack kind of environment when required. These guys don't have access to the servers to log on. All they've got is a security swipe access to actually get into the physical data center. And it's really around taking, the who, what, and where. Who's the person who needs to have access? What do they need to have access to? And where are they from? What do they need to, what parts or what department are they from? What do they need to access as part of that? And really driving that role-based access control down to a lower level for us internally is key to ensure that the right people have the right access. As Al said, we can't use our Microsoft security badges to go swipe into the data center. I was lucky enough to do a tour of a data center about 2 years ago. I had to go through a whole bunch of approvals to a couple of director levels, I think, to get it. It was provisioned for the week I was in Singapore. The moment I walked out of that data center, my access to that data center was axed. So it was, when you think about that from that level, it's really key. Now, this also flows through to you as well as the customer in that you can take advantage of this same role-based access control to ensure that the people you have administering the service for you in your own organizations have the right access at the right time. You don't need to go and give the e-discovery people full admin access to Exchange Online just to go and do discovery. So there are benefits here both from the way we run the service to ensure that the right people are seeing your data when they need to support you, but not being able to go and do the things that they shouldn't be doing. Another great example I had of this was a customer who had some duplication in their environment. There's a whole bunch of events that caused this to happen. Now, we had a service engineer who came back who was supporting this customer and literally came back to them and said, you have duplication of documents in your, so duplicate GUIDs specifically for document records within SharePoint. That's what they said. We can see that, we know it's there. Of course, the first thing the customer came back to them and said was, cool, so what are those document names? We can go and get them fixed. Support engineer then returned and said, I'm not allowed to tell you that. I'm not allowed to look at those document names until you give me permission. A new service request had to be raised. Now, admittedly, that sounds like it's a roundabout or very bureaucratic way of doing things, but the truth is it really delivers a level of, is that me? Delivers a real level of I guess, confidence in the way we secure the service. We don't have guys just sitting there tapping away to see what data's in there, and we ensure that that's locked down at the right level for that as well.
Yeah. So we take that one step further in terms of who has access to your data on the Microsoft side as well. Role-based access control is a very powerful thing for all of you to manage your IT department, your users, and what they can do in the services that they run, whether it's on-prem or online. But for Office 365, we also take that one step further. Firstly, again, a totally distinct network from the Microsoft corporate network to the Office 365 data center network itself. But essentially, we have a tool now called Lockbox. And what the Lockbox tool is this is a kind of custom tool we've developed just for Office 365. But it's about provisioning role-based access control in a time-limited manner. So when someone has, a service request been raised by a customer for Office 365 that needs to look at certain things or change certain settings or those sorts of things, essentially a logged service request is generated, a Lockbox is run, it's run through an approval process, someone approves it, and basically the least privilege role required is assigned to that user for a time-limited point of time. So that temporary privilege escalation is then done in Office 365 Data Center. And all this information is tracked as well. So if you're concerned that Microsoft is looking at your data center or anything like that, you can actually go into Office 365, into the admin center, run, say, a non-owner mailbox access report, and it will list out any admin, either from your organization or from Microsoft, that's had access to any of those mailboxes or anything like that. And it's actually the same reporting pipeline that we use to generate all our own reporting to manage the service as well. And to kind of show you what the tools that we look to run this entire fabric, let's bring up the next little video. So this is a little older demo now. It's not showing our entire environment. But what you can see here is some of our visualization tools as we're looking in particular areas and looking at the kind of servers that we're running. Now, just at a glance, we're looking at Exchange here in North America across a multiple set of data centers. You can see the green ones are online, accepting mailboxes, accepting traffic. The yellow ones are due to be taken offline, so they're not accepting any more mailbox requests, and they're moving their data offline as well. And the red ones here are in the process of being rebuilt, or they've failed, or something like that as well. And we can look at different ways of looking at that information by the role that those particular servers are running, by essentially that information directly. And then we can look at some of the settings in that particular server, whether it's been upgraded to the latest version, what build it is on, or even connect directly with two-factor authentication to log into that sort of environment and do any changes that we need to, or request lockbox access to make that particular change itself as well. Once we look at that, we can start to sort that, and you can start to see kind of the scale that we're operating here My first job in IT, the organization I joined, we used to name our servers by French Renaissance painters. It was kind of like every server was finely crafted. But in this sort of environment, everything's built with PowerShell. The shelf life of one of these servers is a week and a half to 2 weeks. And so we don't even think about them as discrete servers. It's just part of that mesh, brought online, brought offline. And a big change, when we started to run this, the initial approach and kind of the desire of every software engineer or developer is to find out the root cause of the problem. It's why we have 1,700 different rules inside of the management pack and those sorts of things to help diagnose these problems. But running a service, it's all about recovery points. It's get back up and running. We'll debug it later. We'll find out what the issue was later. We have time to do that. We don't have time to sit and debug while the service is offline. So for that reason, more and more of our debugging steps are about take it offline, rebuild those 300 servers, those 400 servers, that 3 server, and get them back in rotation. And then look at the logging information that we generate through tools like that. And essentially, we're generating 24 terabytes of information every day as we look at that information. So it requires a lot of processing just to power just the reporting that we look at across that. And that's the same reporting pipeline that you see in the Office 365 reports as well. So, that's really changed our approach of how we structure a product team at Microsoft as well. The traditional approach was you had, the service you were operating, you may have had an operations team, and then you could escalate that to a product team eventually. Most of us moved on to a service IT model where we had the service, we had a tier 1 help desk, a tier 2 help desk, a tier 3 help desk, before we'd escalate to engineering or to the product team through Microsoft support and those sorts of things as well. The next model we moved to at Microsoft, and this is kind of in the BPOS days, was a direct support model. This was the 6-month calls being woken up in the middle of the night. There was a tier 1 team to kind of assess and make sure it was a real IT concern, not some user ringing up about lost Word documents or something like that. And then we'd have representatives of 10 to 12 engineering teams on duty, providing direct support, all scheduled to be woken up at all hours of the morning as well. And that was a great model as well. But it didn't scale. So the new approach that we're doing is this kind of what we call engineered operations, or really a DevOps model here, where we treat operations as a discrete engineering discipline, not the people that are responsible for answering all the issues, but the people responsible for automating any of those issues, taking the learnings from it, and really developing software to take into account the sorts of issues we're approaching as well. So what you see now, rather than going through a tier 1 or a tier 2 approach, you have a software-aided process to associate theory of the issues, draw conclusions from logging information to wake up the right team, rather than wake up every team to try and debug the issue. And then an operations team that's constantly monitoring that approach as well, taking those learnings, refining that software-aided process to escalate those issues faster as well. So really treating this as software, as a DevOps model. Rather than patching and debugging something, we try and do it in code. Rather than fixing an issue on the server, we really don't want that configuration drift. So instead, what we do is we do it in PowerShell, and we roll out kind of a new build of that particular server or that particular component into the service and replicate that across the environment as well.
So, we've spoken about management, we've spoken about reliability, and now it's time to think about how do we secure this service. And for us, security is really important. I needn't tell you what the look is when a service actually gets breached, especially when we start to think about things we see in the news around, credit card data getting pushed out and those kind of things that happen within the service. Your data is important to you for whatever reason. That data is important to you. It may not all be, highly confidential, top secret documents, but the data is important to you and has an impact on you as a business. And so, from a Microsoft perspective, we feel we're the leaders in cloud security. We drive so much security into our products, and the learnings from that really come from the 2 decades we've spent working in cloud today. Think about Hotmail. Hotmail is one of the most attempted hacked services in the world, right? Like it's a huge attack service. It's broad, it's out there. It's one of those services that's been around for so long. And the truth is, a lot of the time, the only real success people get from hacking into Hotmail is from a phishing attempt, so actually collecting data from an end user. Direct hacking into the service is something that we take a lot of focus on and ensure that we can then take those learnings and work those into the service here. So we actually harden the attack surface on the products themselves. We have a lot of work goes into securing things like Exchange and securing SharePoint and securing Link, but also then driving those best practices around how we deploy those services as well. As we continue up outside of that, we then provide customer controls as well. So we want to make sure that as the customer, above and beyond the security that we provide for the service overall, you have the ability to secure your data as well in addition to that. So when we start to think about technologies like rights management server, being able to have encrypted email streams, et cetera, as part of that, it gives you the ability as the consumer of this service to say, you know what, this is something that I'm going to secure, and I'm going to put that extra layer of security in there for my own benefit and my own concern. And that's something that we really think is important to you, and is something that helps push that forward. Now, of course, all of this compliance and security that we have in place is useless unless someone can verify that, right? So we actually have independent third parties that come in and verify that we're compliant with those security standards that we talk about. This is done on a quarterly basis. We don't have, again, it's not something we set and forget. We don't go, cool, we've set that now to password @ and we're all happy. We actually go through and continually have this audited and checked, and we look for ways to continue to harden that attack surface and continue to drive that value back to you as part of that.
Yeah. So really it's a combination of the controls that we do at Microsoft to run Office 365 and the controls that you do as the administrators running and operating the services on behalf of your users that really make up the security posture of your environment. So we do a lot of things by default, but all of you have a different security posture, a different risk posture in the things that you do. And so it's up to you and us to work together to really secure the entire environment, which is very different from what we've done in the past. This is just a quick, we have another session dedicated to Office 365 security later in the week, but just to give you a quick view of some of the things that we do. BitLockering the servers as well to kind of prevent unauthorized access. Rights management services to ensure that data is encrypted at rest, in transit, and those sorts of things. Physical security access and controls in that environment as well, and many other things we do through that environment.
So then that's all backed by our compliance standards. So one of the things from a Microsoft perspective when we start to think about compliance is really driving what compliance looks like for us. And we have a management framework around that. So that really drives from the bottom end, we have management procedures, the procedures we have around how we actually control the service. We have standards that sit on top of those management procedures. And when we look for standards that we adhere to, those standards we look for high water level marks that we can meet. And what we mean by that is things like, we look at ISO 27001, SSAE 16 Type 2, I think is what we're at the moment. We look for standards that we can apply at a high level that will apply across all our data centers worldwide. So when you look at things like the European Safe Harbor Seal Transport of Data Act, while that is a European Union certification and standard, we apply that across all our data centers because it either meets or exceeds other certifications within that region.
So essentially, it's taking those policies and we kind of divide up those policies into their atomic units. And from those atomic units, we kind of build out a control framework of every single thing that we need to meet for all the different standards. And then it's about assembling all those different control points to meet certain standards, and then to base the operating procedures off that in the environment. So everywhere is a consistent single topology, single infrastructure. It may be certified different, audited different, but if it is needed in Europe for one particular certification, it has to be applied to all of our different infrastructure around the world as well.
To give you a view of what some of those compliance standards look like, this is really where we sit today. Now, like I said, this again is not static. In fact, we used to have SAS 70 Type 2 certification and realized that was now no longer a standard that was the kind of
Replaced by
best in class standard.
SSAE 16.
Yeah, so we upgraded that, right? And we continue to get these standards audited. It's a quarterly audit we do. We have an independent third party come in and do that. Now, the beauty around this is that historically, when we look at hosting services today, a lot of people want to go in and start to audit those data centers themselves. Again, part of the service that you're getting here is the fact that you can't physically audit our data centers, but those independent third parties can, and we can provide the outputs of those as a result of that. So you get that level of comfort and confidence that, while we turn around and say we have, EU Safe Harbor Seal and FSMA and HIPAA certifications, that those certifications aren't just us writing on a piece of paper and saying, hey, look, it's there. We're actually, getting those certifications, we're actually driving those and continuing to build on those as we make our way forward.
Generally, these audits are running about 11 months of the year. So between any particular audit, there's about a week of time for us to change things in the audit, take those changes back and put them back before the audits start again. So it's a very constant cycle that we're under to meet all these different certification standards. So We talked a lot about the infrastructure, but just delivering that enterprise class service, it's not just about building and managing it. And what really separates Office 365 and kind of cloud, and you've probably heard us use the term service, we're much more, we like the term service. It's really representative of what it is rather than just cloud. But building this enterprise class service is not just about hosting it somewhere else and managing it. It's not outsourcing. And typically with outsourcing, your approach is to lock the scope and have that same environment 5 years or 10 years later, and everything else on top of that is a change request. But in Office 365 as a service, we actually want you to have the latest and greatest the whole time. It's that competitive pressure for us to keep you upgraded, keep you on the latest and greatest with all the new functionality as fast as possible. And so balancing the reliability of just locking down something and never changing it with the constantly iterative development approach really requires a really strong change management approach. So looking at how we do change management in Office 365, there's a couple of things to talk about. First, everything's done through code. It's done through deployment. We don't do configuration drift across the servers. There is no way we could manage hundreds of thousands of servers if one had a group policy setting here and one had a group policy setting there. It would just grind to a halt very quickly. So instead, everything is delivered through PowerShell, and that actually helps us while we reimage those servers and those sorts of things as we roll it out as well. If there are non-code changes that need to be made in the particular services as well, they go through a long series of reviews, escalated up the chain to very senior engineers as well before they're implemented. And then anyone on the ground, in that recovery mode to try and make that change, has veto power to say, no, this is not the right thing. When we get on the calls, and it's a link bridge, essentially. Everyone is on a link bridge to try and resolve these issues as fast as possible. It's kind of the red button that people press, like, no, wait, that's not what we need to do here. We need to do this instead. And we go off and do another series of reviews as well. And generally, instead of that approach, we just turn off the server and rely on the other ones to take the load as well. Changes that are planned, they're planned long before implementation. Many of these features, even though we have kind of these monthly ship cycles where we release new builds, new code into the service, some of those features can take 6 months to build, 3 years to build. Something like rewriting the Exchange transport layer was a 10-year project for a series of engineers as well. So some of these things are planned a lot in advance. But one of the challenges is that when we have a monthly window, it's not a big deal to say, well, we'll just wait for next month. So what that puts kind of an amount of pressure on us to keep you guys up to date with the latest capability. Is it coming this month or next month? And some of the times it can kind of make its way all the way through. It can start to be rolled out to certain servers. And then as we see the logging information come back and show like a spike in instability or something on those particular servers, we'll roll them back and we'll take them out of production and we'll wait another month before we roll that service out as well. So to look at that, let's just show you some of the features we've rolled out in the last few months as well.
So interesting thing here is how many people think they've rolled out a lot of stuff recently. This is the number of changes we've rolled out in just the last, just over 12 months. You start to think about Office 365. This is what you get as part of the 3-month iteration. Now, some of these features have been visible. They've been really big. They've been things like mailbox size changes or SkyDrive Pro size changes. Some of them have been smaller and things that you probably wouldn't realize. So, for example, we have a message center that we've pushed into the admin portal now that gives you details around end-of-life support for certain browsers or XP. And just to call out some of the big ones that we've had, Link mobile clients were pushed out. We've had a 64-bit DirSync tool. Exchange Hybrid Configuration Wizard was released. Full PDF support for SharePoint Online, right? These are things that we had feedback coming back from customers that we were able to respond to. And if we think about, the keynote yesterday, being able to reduce the cost of failure or being able to change, or, remove that need to put everything through such a slow cycle is how we could respond to these kind of requests. We have an Office 365 for Government offering in the US that we developed. We pushed out Link 2010 for iPads, which is now Link 2013. We changed increased our email storage, and this slide's a little bit out of date from earlier this week, but we've done that again, right? We've taken Exchange storage up to 50 gigabytes for a mailbox and a gigabyte for our kiosk workers, and putting in things like multi-factor authentication for DirSync as well. And as we continue on, we had Office 2013 come out, and we're going to continue to drive that as we make our way forward as well. Did you get the one you wanted?
Yeah, sorry. That one, yeah. So to kind of wrap up here, when we look at, say, a typical like ITIL, operations for Office 365, typically, and these are the kind of ITIL roles that are specified. I like to break it up into, there's two things that you do, is just run the service or grow and transform the service. And in terms of the context of an IT pro, what we're really doing here in this Office 365 environment is taking on a lot of that run state stuff for you. So you can focus on the growing, transforming, adopting the new technologies and those sorts of things as well. There's constant innovations that's happening in all of these platforms here. But really, what we're trying to focus on here is help to give you more time back so that you can focus on growing, transforming the organization, rather than focusing on all that stuff about worrying about hard drives failing, worrying about the weight of your data center on the second floor, worrying about air conditioning, and all that stuff that we can just do so much better at such a larger scale, and you can get that economy of scale, and then focus on the stuff that does make your business or your organization different, focusing on the customer outcomes, the user outcomes, growing the business, expanding, rolling out new technology, and those sorts of things, which are much more critical for IT to worry about now.
And so what this really means, and coming back to the whole idea of if you want to start on a cartoon, end on a cartoon, is really it means that you can then continue to focus back on your users. IT is no longer the place that money just gets poured into and told go and deliver us something. IT is now an area in the organization that needs to deliver innovation. Users are getting everything you're seeing here at home or from other sources, and so you want your users to be happy to come to work. IT should be the heroes of the organization. We should be the ones enabling people. We should be the ones that are, when people come in, they're looking at us and thinking we're just like those, great spy agencies that can do anything and take a pixelated photo and turn it into this amazing high-def image, right? That innovation can only happen when you don't need to focus on all this other stuff around keeping lights on anymore, and that's what Office 365 helps you do.
So with that, I hope you got a lot out of this presentation. Our next presentation, which Ben and some of my other colleagues are giving, is in Arena 2. We'll be talking about Office 365 deployment for those that aren't on Office 365 yet. And for those that are on Office 365, thank you very much. I look forward to speaking to you the rest of the week. So thank you for your time.
The slides are